Alright, so next we're going to learn how to take the determinant. We do that by multiplying, we're going to make kind of an X here, AD minus BC. I just remember it by making an X like that, okay? Alright, let's go through and do a couple examples here, okay? 21, 23, 25, go to your assignment now. Let's look at 21. What I'm going to do is multiply to make an X, and I'm going to highlight here to show I multiply this way, then I subtract with that. So in this case, negative 5 times 1 is negative 5. 0 times negative 3 is 0, so what is my determinant? Just negative 5. That was easy, right? Just make that X. Alright, where did we leave off in this whole crazy process of calling on people? Who was the last one I called on? Alright, it was, you're next, or you answered a question?
I answered.
You want to do another one? Yeah, alright. Kara gets times 2. How would you do 23?
We do 4 times 1, which is 4.
Uh-huh.
Subtract 3 times 5, which is 15.
4 minus 15, so what would be our determinant? Thanks, Kara. Times 2. Alright. Okay, that's how you do a determinant. Now, if you're like, were we supposed to do 3 here? Or just 2 of them? And 25. Cool. Why don't you guys 25 on your own? Just take 20 seconds. Try to do that on your own, and let's see if we get the same answer. Okay, here's what we're going to do. Everyone's going to shout out the answer they got, and hopefully we all say the same number on 3. 1, 2, 3. 7? Let's just go over this, because then I heard a teen at the end, and I was like, wait, hold on. So we're going to multiply there and there, so we're going to get negative 5 minus negative 12. When you subtract a negative, that turns into a positive, so that's going to make it 7. Alright, good job. If you made a mistake, hopefully you see that mistake. Now, why are we taking a determinant? Actually, we use determinants to help us find inverses. Remember, inverses are opposite operations. We end up using those a lot with matrices. Let me go back to your notes now. And that's just, last thing here is going to be how to find the inverse of a 2 by 2 matrix. This only applies to 2 by 2 matrices. So, if I have A, B, C, D, what I'm going to do is I'm going to do 1 over, hey, what is this thing called we just saw it? You do 1 over the determinant, and you distribute that to this. Now look, it's been a little bit switched around, right? Notice A and D switch spots. So I switched spots with A and D. Did B and C switch spots? No, but what happened to B and C? Okay, so now this is just a little shortcut that people have figured out. When they did this, they said, hey, there's other ways you can find the inverses that take a whole lot of time and effort. This is a shortcut. They said, if we just do 1 over the determinant and distribute it to this matrix but modified, switch spots times by negatives, then it makes it a lot easier. So let's actually go through an example here together. Let's find the inverse of this. Well, the first step would be to find the determinant. So Spencer, can you walk us through the process here? How would I find the determinant of this matrix? Uh-huh. So I'm going to do 3 minus positive 2 is what you said. So that gives us a determinant of 1. We like it when the determinant is 1, and I'll show you why. So, according to this formula, we're going to do 1 over our determinant, which is 1. What's 1 over 1? It's just 1, and does multiplying by 1 change anything? No. Now we're going to change our, so this is the inverse is what we're doing, so a to the negative 1. So this was a, and its inverse. We're going to do the determinant, and then what did we change in the matrix? A and D switch spots, so I'm going to put 1 here and 3 there. Because they just switch spots, right? What did we do with B and C? So this is 2, and this is 1. And do I really need to put that 1 over 1 in front? Nope, it's just 1, 2, 1, 3. Now, that means that this matrix right here is the inverse of this matrix. And if you're wondering what does that mean, well, if you take 1050 with me, I'll tell you more what that means when we're in 1050. But basically, if you multiply those together, it results in the identity matrix, which just has a bunch of 1s and 0s. Okay? You'll get to that next year. If we have 1050, it'll be fun. Okay, let's actually do a couple more practices here. Determine whether the matrix has an inverse. If so, find its inverse. Let's keep going with this. So, Tal, will you walk me through how to find the determinant first?
So it's 3 times 2, which is 6. 4 minus 1 is 3.
Okay, so let's write this out here. So you said that's 6. I'm actually going to change this a little bit. So I'm going to say the determinant is equal to 6 minus, and so we're multiplying the 4 and 1, so 6 minus 4. So then that will just be 2, right? Okay, so cool. So we're going to do, I'm going to take 1 over 2, and I'm going to, that's going to be scalar multiplied to this matrix, but Adam, what do I have to change?
Gotta flip A and B,
So that would be, so I have 2 here and 3 there.
and then you gotta turn B and C negative.
Like that. Awesome. Now you can leave it like this, or if you want to distribute it, you can. 1/2 times 2 is just going to be 1. 1/2 times negative 1 is negative 1/2. 1/2 times negative 4 is negative 2. And then 1/2 times 3 is 3/2. I'm actually not sure if on the answer sheet if they distribute or not. We're going to do an example here in a second. But that would be the inverse of the matrix. You just do 1 over the determinant and distribute it with the modified. We have to switch A and D times B by negatives. Good job, Adam. All right, so let's look at 27, 29. Those will be our last ones. 27, let's do 27 together, and you'll do 29 on your own. Daisy, I'm going to start by doing the determinant. How do we find that?
So it will be negative 3 and negative 2, 0.
All right. Now, when you multiply the negative 3 and the negative 1, there's 2 negatives. So that won't be negative. It'll just be 3, right? Awesome. So 3, and then minus 0, so just 3, right? All right. Chloe, how do I change the matrix around? Great. Zero sign doesn't matter, so boom, there we go. Does your answer sheet, does it leave it like that, or does it distribute it? Leaves it like that. And it's cleaner that way, then you don't have fractions inside of it, right? Does that make sense, how we did that? Awesome, okay? Then I want you to start 29, and I'm going to catch up to you in about 30 seconds. Try that out. Let's see if we can get the same thing without up. Okay, let's go through this real quick. Brinley, are we to you? Tell me how you got the determinant, please. Awesome. And so we'll do 1 over that. And then, Josh, how do I change the matrix? 29. Like that? Okay. What do you guys think? Does that match the back? Awesome. Okay, so this was just a brief intro to matrices. There's still a whole lot more we could do with those. We haven't talked about how you can take the determinant of a 3 by 3, or how you can use these to solve systems of equations, or how you can use these reduced row echelon form and cool things like that. So there's a lot more in store, but this is just a good sample. Do you have any questions on matrices? All right, so what you're going to do for the remainder of time is work on your assignment.